Hi students, welcome to Alpha C Learning Program Mathematics class. In previous session we have observed about length of normal chord drawn at t to the parabola y square equal to 4ax as this kind of value. Okay. So this kind of value students we observed for length of normal chord. Now let us observe here what is length of normal chord drawn at one end of latus rectum. Okay. So if this is the parabola y square equal to 4ax, now let us observe here a point a comma 2a. Okay. So this is one end of latus rectum, and now suppose if this is the tangent drawn at this end of latus rectum, you can observe easily this is the normal drawn at this one. Okay. Now the question is what here? What about length of the normal chord drawn at one end of latus rectum? So if you extend this one, it meets the parabola at some other point. Suppose it is t here. Okay. So now LT is a requirement, and what is the necessary thing here in the formula to substitute? It is nothing but t value. So clearly if you compare 2at is equal to 2a, then t equal to 1. So remember, for ends of latus rectum the t values are nothing but plus 1 and minus 1 as far as this parabola is concerned, right? And now let us substitute the value here in this formula. Thereby you can obtain here 4a into, it is 1 plus t square to the power of 3 by 2 divided by t square. Okay, so this is the value here you got, and now this one if you simplify 4a into 2 to the power of 3 by 2, that can be written as here 2 root 2, and hence this value is nothing but 8a root 2. Okay, so this one is here length of latus rectum, length of normal chord drawn at one end of latus rectum. Similarly at the other end if you take, then there it is nothing but t equal to minus 1. So if you take here, suppose this is the other end of latus rectum, if I write a comma minus 2a, then here t is minus 1, and when you consider t as minus 1, then again you can obtain here same kind of value because of this one. So students, now if at all a question asked about what is the length of normal chord which is drawn at ends of latus rectum, if it is at this point or at this point, so far as this parabola is concerned, it is nothing but how much this value? It is 8a root 2. Okay, so this is the value we got. Now the other one is, what is our interest is nothing but the least length of normal chord. When we observed in case of focal chord, we have taken the least length of focal chord is nothing but length of latus rectum, that is 4a. Okay, for that purpose only we have checked just now whether it is coming as from the ends of latus rectum or not. We have taken it as 8a root 2. Now let's observe what is the actual least length of normal chord. So to find the least length of normal chord, students, let's have a glance on this one. That is the length of the normal chord we are taking. That is, suppose if I am taking f of t value. Okay, f of t value, this is 4a into 1 plus t square to the power of how much it is? 3 by 2 divided by t square. Okay, and now as we require minimum, okay, least value, therefore we use just normal calculus, that is f dash t is equal to 0. And if you take here students f dash t equal to 0, then clearly you can observe here this is u by v formula I can use here, that is t square into 3 by 2 into 1 plus t square to the power of 1 by 2 into 2t, and next minus the other value, it is 1 plus t square to the power of 3 by 2 and into 2t, and whole divided by we have t to the power of 4. For minimum or maximum, this value has to be here equal to 0. Okay, for minimum or maximum, f dash t value equal to 0. Therefore, we are equating the value as 0. Now how much we can take here common? This 2 and 2 get cancelled here, and now you can take common here. This is t value, here also t, and next 1 plus t square to the power of 1 by 2. So 4a into, it is t into 1 plus t square to the power of 1 by 2. If you take this value common here, then what is the leftover? Here it is 3t square is the leftover value. Okay, t we have taken out, and this value we have taken out. So this term you got out, and now you got 3t square, this value, and next value here it is t value came out, and now here minus 2 into the leftover is 1 plus t square. This is equal to 0. Of course denominator cross multiplied, gone 0. Now t cannot be 0. If t is 0, it is nothing but what here? That is nothing but here the vertex. And vertex, if you consider students, here you cannot form a normal chord first of all, okay, because it goes like that here, therefore we cannot obtain here normal chord. So t cannot be equal to 0, and 1 plus t square, of course you know it is not 0, hence this value has to be 0. What about this value? 3t square minus 2t square means t square minus 2 is 0. That implies t is what here? Plus or minus root 2. Okay, that means here at the value t is plus or minus root 2, definitely you can observe here minimum value if you take here even second derivative also. Usually we know between two minimum values there exists maximum value, that you can observe at t is 0. As t is tending to 0, this value is here undefined, hence t tending to 0, which is in between minus root 2 and plus root 2. Therefore at plus root 2 and minus root 2 you can clearly observe the minimum value, okay, of the length of normal chord. And now if you substitute this t is plus or minus root 2 here, therefore we can say here the least length of normal chord, okay, least length of normal chord is 4a times, it is equal to 4a times 1 plus t square, 1 plus t square means 2 here, so it is 3 to the power of 3 by 2, right, and divided by t square means it is 2, so that you got here 2a into 3 root 3, which is nothing but 6a root 3. Hence students, we can observe here the least length of normal chord to the parabola is nothing but how much here? 6a root 3. In focal chord, the same thing, if it is focal chord to the same parabola, just we said it is nothing but length of latus rectum, that is 4a, whereas here it is different. Moreover, this least length you can get at the value t is plus or minus root 2. Also at this normal chord, that means at this point t is plus or minus root 2, the normal chord subtends right angle at the vertex. Okay, so let us see here how it can subtend right angle at the vertex. So this is one of the important formula students, so that is nothing but least length of normal chord. And now let us observe here the points, that means at t is plus or minus root 2. So if t equal to root 2 I am taking now, okay, t equal to root 2, then this is the point what here? P of a t square. So a into t square means 2, okay, 2at. 280 means 2a into root 2, right? Now this is one end of normal chord. If this is one end of normal chord, then the other end is you know the formula. I can't say it is minus root 2. Okay, normal chord means if normal drawn at a point P, okay, at a point P meets the parabola, again yet another point, suppose it is Q, okay, if this is T2, what is our formula? Minus T1 minus 2 by T1, okay. So by using this formula students, you can obtain here the other coordinates, that means the other end of normal chord. So you cannot use here this value as minus root 2 here, in that way we are not supposed to consider, right. So this is our formula, in previous session we have done it, and thereby if you make use of that value, here you have taken t value how much? This is our plus root 2 I have taken. Now T2 equal to minus T1 means minus root 2 minus 2 divided by root 2. So this is nothing but what here? Minus 2 root 2. Hence what are ends of this one? It is nothing but a T2 square. A T2 square means this is 8. Okay, so 8a. A T2 square comma 2a T2. That implies minus 4a root 2. Okay, so this is the point actually, a T2 square comma 2a T2. So you got the value as here, this is a T2 square, this value, and 2a T2, that is 2a into minus 2, it is minus 4a root 2. And now they are telling here at the vertex, okay, at the vertex. So vertex of this parabola is a of 0, 0. Now clearly you can observe students what is slope of AP. Okay, what is slope of AP here? the slope of AP, suppose you take m1, right? This m1 is equal to 2a root 2 divided by this, implies it is nothing but root 2. And next value, slope of AQ, okay? And now this is m2. And this value, if you observe, this is minus 4a root 2 divided by 8a. That implies what is the value you got? Minus root 2 divided by 2, implies minus 1 by root 2. Hence, what is our concept here? m1, m2, if you observe, it is minus 1. Therefore, here this normal chord always subtends a right angle at the vertex when it is of the least length, okay? So, the least length of normal chord always subtends right angle at vertex of parabola. This you can even generalize, okay? The least length of normal chord to any parabola subtends right angle at the vertex. If this is the parabola, y square is 4ax, that particular t value also you can tell that is t plus or minus root 2. In general, what is our concept? Least length of normal chord always subtends right angle at the vertex of same parabola, okay? Now in the same way, students, if you take t value as minus root 2, then again you can obtain in the same way the product of these slopes equal to minus 1, okay? So this is one of the important concepts. And next one you observe clearly, suppose the normal chord drawn at the point, okay, the normal chord drawn at the point t equal to this is plus or minus 2, okay, this is plus or minus 2. The normal chord drawn at t equal to plus or minus 2 subtends right angle at focus. This one is here at focus, okay, subtends right angle at focus. So let us observe here what about the condition. So the condition is clearly, suppose the parabola has taken as y square equal to 4ax, right? And now at t is plus or minus, implies, suppose I am taking here a t square comma 2at, and t value you are taking as 2. So 4a comma, this is how much here? 4a, t equal to 2. And next value here, this is focus. Focus is our a comma 0, okay? So 4a comma 4a, and the other part is nothing but here, this is a comma 0. So I am taking, suppose like this, understood? Now, so this is our focus a comma 0, because this is 4a you got. And next one is here, students, what about t2 value? In the same way, just like our previous problem, the t2 value, if you observe to the parabola, it is nothing but what? Minus t1 minus 2 by t1, right? Now what is t1 here? It is minus plus 2. Therefore t2 equal to minus 2 divided by 2. So this is nothing but what here? Minus 3. Hence what about ends of this normal chord? A t2 square. So 9a comma 2a t2, that is minus 6a, okay? Now at focus they are telling, at focus, so at this point focus, now the angle we have to observe, this is a comma 0. So 4a divided by how much you got here? 3a, right? 4a minus 0 divided by this, therefore this slope is here. What is the value now? 4 divided by 3. Now let's observe about this slope, okay? So what about this slope here? Minus 6a divided by denominator is nothing but 8a. Therefore this is nothing but minus 3 divided by 4. Hence these two lines are perpendicular. Therefore what is our conclusion here? The normal chord subtends right angle at the focus when it is drawn at t equal to plus or minus 2. Okay. So your observation, students, t is plus or minus 2 or t is plus or minus root 2. Then what is your observation? If it is t is root 2 here, that doesn't mean t is minus root 2 here. Okay. You have to observe carefully. Every time you must take here this formula, thereby find the other end, and thereby these are the coordinates. With that help easily you can observe whether product of slopes is -1 or not. Okay, so these are here important concepts. These two are, one is least length and the other one is subtends right angle at focus when t is plus or minus 2. Of course, these two conditions actually you can make use of implies and implied by. That means whenever the normal chord subtends right angle at focus, then it is definitely at t equal to plus or minus 2, implied by. And here also, if a normal chord subtends right angle at vertex to this parabola, then t equal to plus or minus root 2. Implies and implied by condition you can make use by taking these two concepts. Okay. Now observe students, suppose normal drawn to a parabola makes an angle theta with x-axis, then find length of normal chord. Of course, this directly you can make use of length of normal chord drawn at t. Okay, to the parabola y square is 4ax. At t, if you take here at t, the length of normal chord is nothing but how much here? It is 4a into 1 plus t square to the power of 3 by 2 divided by t square. So this is here length of normal chord. Okay, no? So now this one is length of normal chord we know at t. But what is here slope of normal to this parabola drawn at t? Slope of normal. Okay, no? Slope of normal drawn to the parabola at t is nothing but how much we have? It is minus t, right? That implies minus t is equal to how much here? Theta is with the x-axis they are telling, implies it is nothing but what here? Inclination. Okay, so this one is our axis of parabola, that is x-axis to this particular parabola, and normal drawn at t meet the parabola again at q, and inclination given as here how much? Theta. Then they are asking about length of PQ, length of normal chord. And again as usual, if this is T1 and if it is T2, T2 is minus T1 minus 2 by T1. Then minus T is nothing but what here? Tan theta. Okay, inclination. So tan theta is slope, which is this value. Implies T is how much here? Minus tan theta. Then that we substitute here in this formula. Therefore from 1, the length of normal chord, under what condition here? When inclination of normal chord is given, okay, equal to, if you substitute 4a into 1 plus tan square theta, that you know it is secant square theta to the power of 3 by 2, and divided by t square, that is tan square theta, right? So this is the value you got here. That implies 4a into it is secant cube theta, and into you can write this value as cot square theta, right? So in this way you can simplify, and however we require, in that way we can further simplify. That is, here secant cube is there, this is cos square actually, therefore we can simplify further. But this is the actual formula. Simply you can make use of minus t is tan theta, substitute the slope value here, t equal to nothing but whatever inclination. Sometimes if it is given as 45 degrees, okay, 45 degrees, directly you can write the value here as 45 degrees, secant 45, root 2 and cot 45 1, again you can obtain formula. Okay, and next one, another important concept students here, that is nothing but if a normal drawn at t1, okay, normal drawn at t1, it is meeting the parabola at some point when t is not vertex. Okay, suppose this is the parabola you have taken, y square is 4ax, and now a normal is drawn. Suppose this is the tangent drawn at t1, then this normal means here it is falling exactly like this. So this is the normal. Suppose this is p, okay, p of a t1 square comma 2a t1, and now this is the some point it is meeting, and we know this is nothing but minus t1 minus 2 by t1. And again here suppose another normal is drawn at the point t2, then they are telling here both the normals are meeting at same point on the parabola y square equal to 4ax. Okay, so this one is nothing but suppose q of a t2 square comma 2a t2. Okay, so that is the data given in the problem. Normals drawn at T1 comma T2. This is normal drawn at T1 and this is normal drawn at T2. Meet the parabola again at another point. Okay, again yet another point. Some point if it is meeting, then under this condition we say here T1 T2 equal to 2. So don't confuse here the previous formula. What is our previous formula? The previous formula contains one and only one normal, whereas here this formula is containing two normals. So remember, in this way, this is the formula for 2 is the number you got, so for two normals. Okay, in that way you remember this one as the formula. Here you are not supposed to write T2 as 2 by T1 for the other end of the normal chord drawn at T1. So now this is T2 and this one is T1. So this is the condition. In some problems we can make use here. So this formula is exclusively for what here? Two normals drawn at two distinct points, and then both the normals, they are meeting again at one point on the parabola. Okay, so how we got this result? All of you know very well the equation of normal drawn at T1, right? So normal drawn at T1, what is our formula? To the parabola y square equal to 4ax. Okay, so normal drawn at T1, this is nothing but here we know yt1 is y plus xt equal to 2at plus at cube. Then if it is meeting, okay, meeting the parabola, meets parabola again at, suppose this is meeting the parabola again at, let us take T3, okay, because already T2 is there in the problem. Then what is our T3 formula? It is minus T1 minus 2 divided by T1, okay, because of this nature. So if this is the P of T1 and it is meeting the parabola at some other point, and now this point I am taking here a T3 square comma 2a T3, that only we are representing as T3. Okay, now then this is the value we got. Now at a point Q again you are taking, okay, at a point we are taking again a normal, and this is also meeting at the same point, okay, at the same point. Then what about here? That is normal drawn at, okay, normal drawn at T2, and this is meeting parabola at what point? At T3 again, right, at T3 again. Then what is the formula now? T3 is minus T2 minus 2 divided by T2. So both the values are equal to what here? T3. So if you consider this as 1 and this value as 2, then from 1 and 2, from 1 and 2 if you equate minus T1 minus 2 divided by T1 equal to, this side if I write, it is nothing but minus T2 and minus 2 divided by T2. So both the reciprocal terms we are taking one side, then this is the value you got here. So T1 minus T2, and now here if you take LCM, it is T1 minus T2 divided by T1 T2 equal to T1 minus T2. Now here T1 is not equal to T2 because you are taking two separate normals, therefore this value we can cancel. Now if you do cross multiplication, so what is our value here? It is T1 T2 is equal to 2. So one of the standard results. So remember, in this way RHS is 2 implies there exists here two normals. One is drawn at T1, the other is drawn at T2, meeting at same point again on the parabola, right? Now observe students, this is one of the important properties in normal, that is the tangent drawn at one end of focal chord. Okay, so observe here tangent is coming and next focal chord is coming, again normal also coming. All three are involving in this property, students. Moreover, this is not only for the general form of parabola, but to any parabola you can make use of this result. Okay, so the tangent drawn at one end of focal chord of the parabola is parallel to normal drawn at the other end of same focal chord. Usually you know tangent is perpendicular to what? Normal. So suddenly if you observe the word tangent, normal, parallel, then immediately we have to understand the concept. What is the concept here? Tangent is drawn at one end of focal chord. The chord is here passing through focus. Okay. So this is the tangent, and what is slope of this tangent here? So slope of tangent. Okay. Slope of tangent drawn at t. Drawn at t to the parabola y square equal to 4ax is, what is our formula? 1 by t. Now what is the concept they are telling? This tangent is parallel to the normal drawn at the other end of the focal chord. So Q is other end of focal chord, and all of you remember very well, if these two are ends of a focal chord, then the property is T1 T2 is minus 1. Okay. Therefore the coordinates are a by t square comma minus 2a divided by t. So these are our coordinates. Or you can use simply, suppose first I am writing a t2 square 2a t2. Okay, na? So this is the value where t1 t2 is how much here? Minus 1. So what is now slope of normal drawn at t2, right? So slope of normal here, this is normal we are taking, drawn at t2, right? Drawn at t2 to the same parabola where t2 is the other end of focal chord. So what is this formula for us? It is minus t2, and this one is here 1 divided by t, and this is minus t2, right? But what is this minus t2 with respect to this property? It is nothing but how much it is? 1 divided by, okay, minus 1 divided by t1. Understand? So that implies here you can simply slope of normal drawn at t2 is nothing but minus t2, and you can simply make use of the property. What is the property? Suppose this is t1 here, t1 here, you know clearly t1 t2 is how much here? Minus 1. So T2 is how much here? Minus 1 divided by T1. That implies minus T2 equal to what here? 1 by T1. As we have started with T, therefore this is equal to how much now? Clearly 1 by T. As these two slopes are one and the same, therefore we can say slope of tangent, that means tangent at T is parallel to normal drawn at the other end of focal chord. One of the important properties, students, which we can use in some other problems, right? Now let us observe, students, the equation of normal. The equation of normal, we know it is y plus xt is equal to 2at plus at cube, right? And now if I take all the values on one side, then it is at cube plus 2a minus x into t, and minus y is equal to 0. Okay. Now t being a third degree, that means here cubic value is there. That implies here this equation is having 3 roots. The 3 roots may be here in a different way. They may be here, the 3 values cannot be imaginary because these coefficients are here real coefficients. As long as coefficients are real, if at all imaginary roots occur, they occur pairwise. Hence here there must exist at least one real root. Okay, as there exists at least one real root implies there must exist at least one normal to a parabola. So this one, of course, we have taken the standard form y square equal to 4ax, right? Y square is 4ax we have taken, but to any parabola, if you consider there exists at least one normal drawn from, okay, normals exist many, but drawn from here, which one here? A point x1 comma y1. So if this is the parabola, students, now if I am taking here, this is a tangent, then if this normal is passing through some point here x1 comma y1, which is exclusively inside the parabola, the point must be here inside, because normal means always it is a chord except this one, that is the axis. Okay, so it is a chord implies the point has to be always inside. And now if this normal is passing through x1 y1, then what about here? As here normal passes through x1 comma y1, okay, normal is passing through x1 comma y1, that implies here at cube plus 2a minus x1 and into t minus y1 is equal to 0, right? And now this is the normal, but you have taken at what point? At square comma 2at, right? And now suppose here there may exist two normals, or there may exist again three normals. Now you may think here that two normals means one root is imaginary. No, but it is not in that way. Okay, two normals, if I am telling here two normals are coinciding and the other is coming, that means equal roots, two are equal roots and the other one is just a next value. Suppose the values may be 3 comma minus 1 comma minus 1. Then also we are having here three values seems to be, but these two are equal implies these are coincident. Okay, and next one, this is the other one, so that we are telling two normals. It can be one normal or it may be three distinct normals. And let us observe later in what conditions you can obtain exactly 3 etc. But now our interest is what about the nature of this equation and what is the nature of the roots of this equation. Suppose T1 and T2, T3, three roots we are getting. Okay, this is T1 and next one this is T2, a T2 square comma 2a T2, and next this is the other value, that is a T3 square comma 2a T3, right? Suppose you got here three values, then these three normals always they are concurrent. Okay, these three normals always they are concurrent at a point. This is nothing but x1 y1. At that stage we call here this a of t1 and next value it is nothing but b of t2 and next c of t3. These 3 points are known as co-normal points. Okay, co-normal points because these three normals they are passing through a common point x1 comma y1. That's why we call them these 3 points as here co-normal points. In other words, we call it as feet of normals. Okay, so now you can understand clearly, students. That means here, as this is a cubic equation in T, there exists maximum number of real roots is 3 real. Okay, so maximum number of real roots is here 3. Maximum real roots is 3 implies if at all 3 roots exist, 3 real roots exist, then 3 distinct normals exist, and those 3 distinct normals they pass through always a common point, that is x1 y1, which is inside the parabola, and hence we call these 3 points as here co-normal points, right?